So in this lecture we're going to talk about contours, and again I just thought this would be easier to talk about it in a lecture rather than at the desk. So a contour line that I've described before is just a line that joins points of equal elevation, and you can find the contour interval in the legend. So this diagram here shows the contours as they would appear on the map in the bottom half of that diagram, and its physical representation of the topography in the top half of that diagram. It's a hill. Contour patterns show the shape of the landscape. So contour lines that are close together show steep slopes. Contour lines that are far apart show gentle slopes or no slope at all. If they're evenly spaced, it's a uniform slope. If the spacing decreases when going from high to low, the slope is convex, as you can see there in the diagram. And if it's the other way around, it's concave. So you can read the topography in your head just by looking at the shape and position of the contour lines. One thing that's useful to also read from contour lines and combine that with your ability to measure distance is the gradient, how steep a slope is. And the gradient is just the height, or the contour interval of the distance between two places that you're interested in, divided by the horizontal distance. And it's expressed as a ratio. So a 1 to 10 gradient is 1 unit up, or in fact down, and 10 units across. So a 1 to 1 ratio would be 45 degrees. Okay, so you can see that diagram there just shows the what each of those different gradients would actually be like. Okay, so now we're going to look at doing a cross-section. To do a cross-section, we're visualising what the shape of the land would be just straight from our topographic map. So if we have a look at this topographic map, which is of Perisher Valley, is vicinity of Little Thredbo River. Now, we could do a cross-section from Penderley Gap over to Bull Creek, and we would be looking at how each of these contour lines, we would represent each of these contour lines onto our topographic cross-section. Now, that's what you need to do as part of one of your exercises. I'm not going to do it now because it would just take forever, and it's not great using a big thick pen. So I've simplified it by using a pre-made diagram. Like so. So here we have just a simplified diagram showing some contour lines. So here we have a spot height of 476 metres. We've read off the map that the contour interval is 10 metres, and we've got one other contour line marked with its elevation. So just double checking that, so it's 476, we're obviously going down the hill, that would be 470, that would be 460, 450, 440, this one over here would be 430, because we know it goes down. We're looking at the whole landscape and double checking as we go along. I mean, they could go up again, like this one, 470, 460, now that's 450, that must be 460, so we've got a bit of a flat area between two hills. All right, so just make sure you understand your elevations and what each of the contour lines mean. It can get quite difficult, especially in mountainous areas. You need to be very careful. Okay, to do a cross-section, you take another piece of paper, any piece of paper with a flat edge. We're going to do our cross-section from point A to point B over there. We take our piece of paper, it just makes it, thankfully, and wherever we intersect a contour line, we put a mark on our piece of paper. So there's a mark there, a mark there, a mark there, a mark there, one there, one there, one there, one there, and one there. We then need to make sure we know which of those contour lines are represented by those marks. So this one over here is 440. This one here is 450. We know that's 460. That's the same one, so that's 460. We're going up, that's 470. That's the same one, that's 470. And we're coming down 60, 50, 460, 450, and 440. Okay, so once we've done that, we can get rid of our map. And we take another piece of paper, or ideally what you would want to have is graph paper. That works really well. But we'll do our own graph because it's just easier to see. So we take our x-axis along there and we make a y-axis. Now the scale along the bottom is going to be the scale of our map, which in this case, just made it up, but let's say it's 1 to 25,000. So that would be 1 centimetre equals what? 25,000 centimetres, or 1 centimetre equals 250 metres, which is fine. That's the scale we're going to use as we go along across the landscape. But if we use the same scale for our y-axis as 1 centimetre equaling 250 metres, so we have 1 centimetre there. Now if we said that was 250 metres, the range of elevations of our topographic map only go from 470 to 440. So we would have a very flat representation of the elevation and wouldn't really show us very much. So we need to exaggerate the vertical scale. Now you can pick a vertical scale of whatever you like, trial and error, to try and get the best representation of the topography on your diagram. Now, I think you're asked to do a couple of different vertical exaggerations in the exercises, but really what you should be doing if you're doing this to really see the elevations, to try and work out which one suits your topography best. Perhaps a shallower one, a smaller one where it's very hilly, and a bigger one if it's flatter, just to exaggerate the topography. I'm going to use a vertical exaggeration of, I'm going to pick one, let's say vertical exaggeration of 5. So it needs to be 5 times bigger, the vertical scale, than the horizontal scale. So if our horizontal scale is 1 to 25,000, what would be 5 times bigger? Not 25,000 times 5, remember right back, you do it the other way because you want a larger scale. So you would divide 25,000 by 5, so it's 1 to 5,000. Okay? So your vertical scale would be 1 to 5,000, that's a larger scale, and you've exaggerated it. So in that case, with a vertical scale of 1 to 5,000, then that's 1 centimetre equals 50 metres. And that should work relatively well. Is it going to work well? 1 centimetre equals 50 metres. Let's have a look. Let's mark on the map our scale 2, 3, 4, 5, 6, 8, 9, 10. So then this would be 50, 100, 200, 300, 400 and 500. And to plot our cross section, oops, it's not quite long enough, make sure you don't fall into that trap. Do you then plot your on your topographic cross section the elevation at each of your tick marks? So here we have 440, so that would be there. Then we have 450. Okay, at that tick mark, you can use a ruler. This is where graph paper comes in handy. Okay, so 450 is about there. Move that along there. 460, just doing it by eye for the sake of speed. 460, then 460, It's not quite right, is it? Anyway, 470, 470, should have used graph paper, 460 and 450. And then we would draw a line to show our cross section. And quite honestly, that's not a very good topographic cross section because our vertical exaggeration wasn't chosen well. To get that, to be able to see much more of the topography, you would have to exaggerate that vertical scale even more. And I'll let you do that with your topographic map. I think you get the idea of what's required. I don't need to do that again. All right, so vertical exaggeration is important to get that right. Okay.